Welcome to the latest in this advanced series of ADF Insider. My name is Grant Ronald and I'm a Senior Group Product Manager in Oracle's Development Tools. And this ADF Insider session will focus on using Groovy in Oracle ADF applications. The session will cover an overview of what is Groovy, why would you use it, when should you use it, a brief introduction to the Groovy language constructs, and then I'll spend the most of the session focusing on, using demos, the built-in ADF support that we have for Groovy. So the first question, what is Groovy? So Groovy is a Java-like scripting language that's dynamically compiled and runs inside a Java virtual machine. And it takes its inspiration from languages such as Python and Ruby. So it can access Java APIs and your own custom classes that are available inside the JVM, and really gives you the power of Java without having to drop into full-blown Java coding. And this can be particularly useful in frameworks like ADF, where you can use Groovy for writing validation or attribute values. Another feature of Groovy within ADF is because the Groovy code is held within metadata within ADF framework, it means that that metadata can be customized on an application-to-application basis using our MDS framework. So let's take a look at some very simple examples of Groovy syntax. And the simplest one is the Hello World example and how you would print a string. Notice that Groovy doesn't require the semicolon you typically require if you're writing this in Java. The second example shows 2 points, the if-else statement, which should be very familiar if you're already developing in Java. And the second example is a calling out to a standard Java class, which is the calendar class. This third example shows a feature of Groovy, which is maps, where you can have name, value, pairs of data, and an example of how you can print out or access the values within that map. And the final example is another feature specific to Groovy, which is collections, where you can have collections of data. Here we have integers, and then some actions that can be performed on those collections: join, count, and sort. So you get an idea of the kind of power you can have with Groovy and how very familiar it should be if you're already coming from a Java background. So how can you actually use Groovy within an ADF application? Well, there are a number of different places in which ADF allows you to place Groovy expressions. One of the first places you may well experience this is using the ADF Business Components validation. So within ADF Business Components, you can set validation on an entity attribute or at the entity level itself. And when you select to create a validation rule, one of the rule types is a script expression, and this allows you to define a validation rule that's written using Groovy. You also have the option of not only defining the validation rule in Groovy, but also when the validation actually executes can also be a Groovy expression, and the error message it's displayed can also be used accessing a Groovy expression as well. And the best way to show you this is through a demo. So in this first example, I'm going to create a validation rule on my customer's entity object, which is a script expression. So this will allow me to type in a Groovy expression, and let's start with something like, and this is our print statement, which is just printing out the value of these two attributes, which is useful for debug purposes. And then there's the rest of the code. So what this code here, this Groovy expression is, it's checking the income level. If it's below 30,000, then the credit limit must be less than 1,000. If it's between 30,000 and 49,000, then the credit limit must be less than 2,000. And then our final rule is that credit limit must be less than 3,000. So this has given us flexibility to write a much more complex validation rule without dropping into the full-blown Java code. So there's a Groovy expression for the rule. I can also add a Groovy expression as to when this rule is actually executed. So I can say something like NLS territory is not equal to will mean that this rule will only fire if our customer is not based in America, as defined by the NLS territory. And in the final example, I'm going to set an error message. And let's have this error message as something like and then I'm going to access an attribute, and we're going to make this cust last name. However, what I can do is cust last name dot. So really what we've done is extend, rather than just calling an attribute, I'm calling the value of that attribute and then the Java method to uppercase, which will translate the value of that field to uppercase as part of the error message. So let's test that. And there's our first customer, and this first customer, they're based in the US, so let's give them a credit limit of 6,000, and that's okay. And let's go to one of our other customers who are based in, for example, this one's based in India, and let's give them a credit limit of 2,000, but it doesn't like that. This credit limit is too high for, and then we see the surname in uppercase, and that's because we've given them a credit limit of 2,000 when their income level is actually low. So this needs to be less than 1,000, and that's accepted. So let's look at another example where we can use Groovy within ADF. And again, within the ADF Business Components, we allow you to define Groovy expressions for attribute values. So you may define, for example, that the default value for an attribute is based on a Groovy expression. Or more typically, you might have a calculated value where something like a line total is calculated from quantity times unit price. So again, let's show you this using a demonstration. So in this next example, let's add a transient attribute to our order items view. And this transient attribute will use a Groovy expression to calculate a line total. So we have a line total, which is of type number, and the value will be a Groovy expression, and that Groovy expression, quite a simple one here, is quantity, which is an attribute, times unit price. And then you can see the full expression here. The second example we're going to use a little bit more advanced this time, but let's look at the account manager ID for our customer. And this time we're going to use a little bit more of a complex Groovy expression using some of the Groovy features such as lists. And here I've defined a list which says the duty managers for a week: Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, etc. And what I'm basically doing is, depending on the day of the week it is today, we'll pick a different manager as the default for the account manager. So we're using the day of the week as an index into this list. Let's OK that. And let's run and test. So there we can see a line total, which is unit price times quantity, and that will obviously update to reflect the new attribute values. And if I go for a customer and I create a new customer record, then the account manager is defaulting to 101. And let's go down and just change my current date. And now let's try that again. And there we see we have a different defaulted account manager because we have a different current date. Our ADF support for Groovy also includes some ADF specific built-in Groovy functions. So for example, if you want to access the current date or the current time, which might be useful for defaulting an attribute value, you can use adf.currentDate and adf.currentDateTime. If in your processing you reach some sort of error or warning, this can be raised using a Groovy expression, which will then be handled as part of the ADF default error processing using something like adf.error.raise, which will allow you to raise an error, and adf.error.warn, which will allow you to raise a warning. And again, let's show this in a demonstration. So in this example, for the customer's date of birth, we're going to default the value to a Groovy expression, which is adf.currentDate. So that will default to the current date for a new customer. Let's look at another example here. Here's the validation rule we set up earlier, where we're checking for people with low income levels, checking their credit limit. Let's extend this use case slightly to say that regardless of whether the rule fails or not, we want to indicate a warning message to the operator that they're about to change the credit limit for somebody who's on a very low income. And if we do adf.error.warn, so this will display a warning message with, and I've set up a resource bundle string, so that refers to a particular warning message. So regardless if this validation rule passes or fails, we're going to indicate a warning message to the operator as well. So let's OK that, and let's run and test. Here's a customer. Let's find one on a low income level. Here we are. Let's set it to 100, and we navigate away. We get a warning message. So the validation's passed, but we've added in a Groovy call to display a warning message. And if we're to create a brand new customer, we have their date of birth defaulted as well to the current date. Another Groovy support feature we have within Oracle ADF is built-in row set functions. So what's a row set function? Well, it's a Groovy expression that can work across sets of data. So for example, we have customers, and a customer has one or many orders. And we have a Groovy expression that, when based on a customer's attribute, can perform that function, for example, sum, average, count, min, max, across all the orders associated with that customer. So here's an example of orders view, which is a view accessor, dot, and then the function, which is in this case sum, and then the parameter is which attribute within orders that we want to perform the sum over. In this case, the sum of the order total. And again, let's show a demonstration of row set functions in Groovy. So let's go to our customer's view object, and let's create a new transient attribute, and we'll call this order average. And this is of type number, and it's a Groovy expression. And if I call orders view, which is the name of an accessor to the orders view, dot avg for average, and then the attribute I want to average out, which is order total. And let's run and test that. There's a customer, and in fact let's look at this view, and there we can see the average of the order totals. And obviously we can do the same thing with some minimum and maximum as well. So what if you have in the situation where as part of an attribute value or as a business components validation rule you want to call out to a Java method? Well, within ADF Business Components we provide two helper classes that allow you to call out to Java methods. So for within an attribute value, if you use the Groovy syntax adf.object.method name, that will call a method associated with your entity object. And within a validation rule, if you want to call out to a Java method, then the helper class is adf.source.method name. And again, let's see this in an example. So in this example, we've created a helper method, and this method called nixVal returns the nix value in a sequence that's passed in as a parameter. And I've added this helper method to the customer's info Java file. So now what I'm going to do is go to the attribute for customer ID, and the default value for a new customer should call that expression. So to call that expression using Groovy, adf.object, which is my helper, and then nixVal is the name of the method I want to call, and I need a parameter, and the parameter is the name of the sequence. So adf.object.nixVal is allowing me to call the nixVal method in my entity info class. And let's test that. And there, my customer. And if I create a new customer, we automatically get the new customer ID coming from a sequence. The final example shows a neat feature of Groovy where you can access the control hints associated with your entity object. Now, why might you want to do this? Well, it could be that as part of your error message you might want to refer to the actual label of the field through the control hints, or maybe use the tooltip text as part of help that comes up in your validation error message. And we can do this using a helper class that has the Groovy expression adf.object.hints, and then the attribute you're referring to, and then the hint, for example, tooltip or label. And again, let's see this in an example. So in this final example, I'm going to enhance the error message I have here with a Groovy reference, and that Groovy reference will reference the label or the control hint for the attribute. So now my error message will be the credit limit is too high for, and I want to refer to the label of the attribute. And the way I can do this is by saying adf.object.hints, which will take me to the control hints, cust last name dot, and then the control hint, which is label. So whatever the label is defined using control hints for this field, that will be reflected in the error message, which also means that if at any point I change those labels via the control hints, the error message also refers to those as well. So let's OK and test that. Let's bring up a customer. And let's credit limit to 6,000. And there we can see the error message says the credit limit is too high for customer surname Nolte, because it's pulling that string from that control hint. So to summarize, with Groovy you get access to the full power of Java without diving into full Java coding via the various declarative hooks that we have within ADF Business Components. I think it's also worth recognizing that Groovy expressions are maybe not something you'd use all the time, but just gives you that flexibility when you need it. For more information, there is a paper available on the Oracle OTN network, and the link below also shows you the home page for Groovy. If you'd like more information, you can access it from the OTN network using the link shown. Thank you very much for listening.